In this video, we're going to review one of the more important things we've learned this year, and that's L'Hopital's rule. So what does the rule say? It says if we're trying to find the limit of these fractions, so f of x over g of x, if both of the limits of f and g are 0, so we get 0 over 0, or infinity over infinity, if either of these happens, we can take derivatives of these individual pieces and then retry the limit. All right, so we're allowed to use this idea of derivatives to help us with this earlier concept of limits. All right, so in this video, we're just going to do a bunch of examples to kind of review it. We'll do some more with exponentials and logs we haven't done before. So for all of these, you can try them before I go over them. I just pause the video. But remember, one important thing is not to say that like this is equal to 0 over 0. All right, the AP graders don't like that. So what they want is you to kind of go to the side, show that these one-sided limits, or sorry, not one-sided limits, but like the limits of the top and bottom are 0 separately. And of course this one, they both are. When we're just evaluating the limits of a polynomial, we just plug in the number. So we get both of these are 0, and then you can show that you're doing L'Hopital's rule. So this is just a simple way of showing I'm doing L'Hopital's rule. And then do the limit. Make sure you rewrite the limit because it's still a limit right now. But now instead of x squared minus 9, I take its derivative. Instead of x minus 3, I take its derivative. And now I try to redo the limit. Sometimes you'll have to redo L'Hopital's rule, so just do everything we just did again. But in this case, I just plug in 3, and I get 6. All right, so make sure you're doing this consistently whenever you're trying to do L'Hopital's rule. Again, multiple choice questions in the long term, it doesn't matter because you're just circling an answer. But for free response, in order to get all the credit, you have to show these two things to the side. All right, so just as a good habit, we're going to do that. Limit. Let's x approach to 0, 3 to the x minus 2 to the x. Plug in our values. 1 minus 1 is 0. And the bottom one almost feels like you don't even have to show. You just plug in 0, you get 0. So again, we get 0 over 0. Now we can do L'Hopital's rule. We have to find our derivatives. All right, so in the top, these are the ones you might not have memorized because they're not as important as e to the x. But any exponential, you get back the same thing. The only thing that's different when it's not e to the x, you have to multiply by this extra natural log part. All right, so these are going to be the two derivatives we have. Then the bottom is just 1. And now we just try to plug in 0 again. And anything raised to 0 is 1, so they just go away. And we get this as our final answer, which I don't think you could ever like guess this was going to be the answer to this limit without being able to do L'Hopital's rule and know how to do your derivatives correctly. All right, another one. Let's check the limits first. We get sine of 1. What is sine of 1? I have no idea. All right, this is one that's trying to like trick you into doing something that you're not supposed to do. You want to say this is 0. We have no idea what sine of 1 is. You could put it into a calculator and figure out what it is, but it's not like a nice number. It's not one of those like pi over 3 on the unit circle or pi over 2. It's just a value 1. So this just gives you some arbitrary number. My guess would be it's like, I don't know, 0.8 or something like that. You can put it in calculator and see. But this is not 0. All right, so we don't have to do L'Hopital's rule. We just get 0 over sine of 1. And 0 over anything that's not 0 is 0. So the final answer for this one is 0. And yeah, always put these types of problems in to make sure you're checking to do L'Hopital's rule first. If you just thought you could do L'Hopital's rule, you get 1 over cosine and get some other answer. But make sure you can actually do L'Hopital's rule before you actually try it. All right, limit is x approaches 0 from the right. All right, the only reason there's a one-sided limit here, that little plus, is because you can only plug positive numbers into the natural log, so the 0 from the left doesn't make sense. Let's try our limits. All right, so the natural log graph looks like this. So as I get from 0 to the right, I go down to negative infinity. The limit as x approaches 0 from the right of sine of x. All right, sine looks like this. So as I'm coming from 0 from the right, I actually go towards 0. So when I get infinity on the top and 0 on the bottom, so I can't do L'Hopital's rule. I have to figure out what would this be. I'm taking a big number and dividing it by a really small number. Dividing by small numbers makes numbers even bigger, so this is going to like double infinity. So this answer is just negative infinity. All right, really kind of weird problem where you're just trying to figure out what's happening. All right, but you can't do L'Hopital's rule again. So just make sure you're always double checking that you can actually do it. And this one says your turn, but again, you could have been doing all these. So take it a second. All right, try this one on your own, see what you get. But I'll start working out the problem now. Again, really important oops. All right, so I did a mistake. I put in the zeros before. The zero shouldn't be there when you're doing the limit part, when like you're writing out the limit. But now I can put in the zeros. So that's that. All right, so we get 0 over 0, and that's good because now we can do L'Hopital's rule, the things we're actually trying to practice. On the top, we take our derivative, we get e to the x minus 1 over 2x. All right, now we check again. All right, before I write down anything, I kind of just do it in my head, and it seems like I'm going to get 0 over 0, so I'm going to write it out again. Again, if you do have to do it multiple times, that's fine. But I do get 0 on the top. On the bottom, this one's the more obvious one, it's 0, because you're just putting in 0. You get 0. So I do get 0 over 0 again, which means I'm going to do L'Hopital's rule again. Derivative of the top is just e to the x. Derivative of the bottom is 2. And now I definitely can't get 0 on the bottom, so now I know I can just plug in my value. And I get 1/2 as my final answer. And not something you would probably guess by looking at this, but doing L'Hopital's rule, making sure you write out all your limits, shows you the answer. All right, so quick summary. All right, make sure you show that the limits go to 0 or infinity separately. Again, on a multiple choice question, it's not going to matter whatever you write as long as you get the right answer. But free response questions, normally writing those limits separately and showing you're doing L'Hopital's rule is like one of the 9 points of the problem. All right, so make sure you get those, that 1 point by writing out that stuff and then putting that little like equal sign with the L'Hopital's rule to show you're doing L'Hopital's rule. I remember you're not doing the quotient rule even though you're taking derivatives of this f of x over g of x. L'Hopital's rule is different. This is where you actually like want to just take the derivative of the top and derivative of the bottom, which is what you try to do sometimes with the quotient rule, but you don't have to do the full quotient rule, just taking derivatives of the top and bottom.